Hello there, my name is Mrs. Groovy Groves and I'm here to help you with the distributive property. This is specifically going to be pages 7 in your Unit 6 packet. This is going to be pages 7 through 11. Okay, so this is all about the distributive property. So write this down. Now, the root word of distributive is to distribute. So, if I was to ask you guys, can you please distribute the JRs to everybody in the class? What would you do if I said, please distribute JRs to everybody in the classroom? I'm pretty sure you would say, I'm going to hand it out to every single person. So the distributive property is such that the distributive property is something that's technically like this. If you have A times the quantity, B plus C, that means you have to take A times B plus A times C. Or if you have A times B minus C, you would have to take A times B minus A times C. That sounds kind of confusing, and I just want you guys to understand this with algebra tiles, okay? Here we have algebra tiles. These squares, well, first of all, let's start with the unit, okay? This small unit right here is one unit, you know? And you have your positive 1 and negative 1. So this right here, say this is a positive 1. Well, this side right here that I highlight, you know, if this is a 1 by 1, the area of that little square is 1. Now over here, we have this side is 1, okay? As you can see, this dimension here is the same exact dimension there. And what we don't know is this side here, so we're going to say that that side there is x. So the area of a rectangle is base times height, and that's why we get x for this right here. And then, as you can see, if you take a look right here, if this right here is x, and take a look at the square right here, you basically have, I'm going to draw this in black, you basically have x and an x. If you have x times x, that is x squared, ladies and gentlemen. So these algebra tiles, this, when you see a shape like this is an x squared. When you see these rectangular shapes, skinny rectangular shapes, that's considered to be an x. And when you see the small squares, that's considered to be a 1. And normally a red would be negative, or it just depends. Like normally we have red and blue, or green and yellow. You kind of designate which one's going to be x and which one's going, which is going to be positive and which color is going to be negative. As you can see in this third picture here, we have a positive 1 and the red one is a negative 1. This x here, it's a blue, it's a positive x. It's a positive x, and the red one is a negative 1x. This blue here is a positive 1x squared, and this is a negative x squared. All right, so on page 7. On page 7 it says, draw the visual representation for each problem. Write and box your final answer. So on number 1 it says 3 times the quantity of x plus 3. This is what we're going to do. This right here, I told you, represents x. And let's draw 3 little squares, okay? That right there, I just modeled x plus 3, okay? But I have this right here, it says 3 groups of x plus 3. I have that 3 times. So since I have 3 groups of x plus 3, I'm going to draw it out. And then the proof is in the pudding, right there. What is it that you have? how many x's, what are your like terms? These would be considered like terms, and then these ones are separate. So this simplifies to 3x plus 9. All right, on number 2. And again, what we're practicing is the visual representation. We're practicing the modeling. So the first thing you want to do is you want to model x plus 4. Okay? So remember that x looks like this, you know? It looks like a rectangular, skinny rectangle. So I'm going to model x plus 4. 1, 2, 3, 4. That is x plus 4. And right here, it says I have 2 groups of x plus 4. So since I have 2 groups of x plus 4, I now have, this simplifies to 2x plus 8. All right, if you're getting the hang of it, try it yourself. And then you can always pause the video. On number 3, I'm going to represent 2x plus 1. I have an x. I'm going to represent it all in one row. So there is my 2x plus 1. But I have 4 groups of that. So I need to draw that. I have to have that a total of 4 times. All right. You don't have to write x in it if you don't want to, as long as you understand that these are x's and the small squares are units of 1. So what is it that we have here in total when we combine our like terms? I have 8x plus 4. All right, number 4. Let's look at what's in the parentheses, and it says 3x plus 3. So I have 3x's plus 3. So I'm going to draw them a little bit smaller. So here's my 3x's, and then I'm going to have my 3 units right there. So now I have, it says that's 3x plus 3, but I have how many groups of it? 2, good job. So I have 2 groups of 3x plus 3. So what does that simplify to? What do you see? Count up your x's, count up your units, the squares, and you should have 6x plus 6. All right, moving on, number 5. So in our parentheses, it says we have 4x's plus 2. So I have 1, 2, 3, 4. And we have 2 little units. All right, well, how many groups do we have of this? We have it 3 times, 3 groups of that. So I need to draw it another 2 more times. And I really recommend, like, if you understand this, I recommend you just pause the video and just fly away and do it yourself, you know, and then come back and check your answers. Then that way you don't have to watch the whole video. You can just move to where the final answers are. So as you can see, I have 3 groups of 4x plus 2, and that would simplify to 12x plus 6. All right, number 6, I have 2x plus 1. In the parentheses, I have 2x plus 1. I just modeled 2x plus 1, but holy Toledo, I have 6 groups of that. So I'm kind of starting to wonder if maybe you might see the pattern of what's going on. I mean, you know me. We do a little bit of modeling and then we graduate and move on from the modeling. So, but I don't know if you're ready to graduate just yet. If you have 6 groups of 2x plus 1, what is it that you have in total? Good, 12x plus 6. Excellent. All right, number 7. So I have in the parentheses, I have x plus 7. So I have x, and I have 1, 2, 3, 4, 5, 6, 7. And I have that 5 times. I have 5 groups. Oh boy, we're going to have to do a lot of drawing, ladies and gentlemen. I really hope you guys aren't just copying me. I hope you pause and don't watch me do this all and you just go straight to where I state the final answer. But if you have 5 groups of x plus 7, then what you must have in total is 5x plus 35. All right, number 8. We have 3x plus 6. Well, 2 times the quantity 3x plus 6. So let's draw what that means. We have 3 x's. We got 3 rectangles. And we have 6 little boxes. And how many groups of that do we have? 2. Excellent. And so that means, what do you see in total? Your like terms. You would see 6 x's and you have 12 units. So that's 6x plus 12. All right, number 9. I have in parentheses, it says 2x plus 5. So let's draw 2 x rectangles and 5 baby squares. And how many groups do we have of that? 4. Excellent. I'm actually making my video right now at school, and I'm really hoping no one calls me or knocks on my door. All right, so this is 4 groups of 2x plus 5. So if you add it all up and take a look, you would have 8x plus 20. All right, number 10, it says we have x plus 1. So let's draw an x rectangle, and a baby square. And it looks like we have 3 groups of that. We have that 3 times. So since we have it 3 times, like I said, the proof is in the pudding, ladies and gentlemen. What is it? Looks like it's going to be 3x plus 3. All right, the last 2 problems. I got, in parentheses, I have 3x's plus 2. So I have my 3 x rectangles and my 2 baby squares. And it looks like I have 2 groups of that. So, add it all up. Take a look. What's staring at you guys? 6x plus 4. And last but not least, number 12. We have 2 groups, 2x plus 1. So we have 2x, let's draw 2x rectangles and a baby square, and we have 5 groups of that amount. 1, 2, 3, 4, 5. It's kind of nice to draw and model because I with the modeling, for me, it just kind of makes sense and just like sinks into my brain easier. Instead of me just telling you what to do, you can be like, okay, Mrs. Groves, I get it. I know what to do now. So what do you see on the board? 10x plus 5. All right, it says, how can you find the answer to 15 times the quantity 8x plus 6 without having to draw the visual representation? So I'm hoping by now you've graduated from modeling and you can tell me what that means. And I'm thinking if you can just see the patterns, if we had like 5 times 1x, that gave you 5x, and 5 times 7 gave you that 35. 4 times 2x gave me that 8x. 4 times 5 gave me that 20. 2 times 3x gave me that 6x. 2 times 6 gave me that 12. 3 times x gave me that 3x. 3 times 3 gave me that 3. It happened in every single instance. So if you do 15 times 8x, 15 times 8 is 120x plus, and then 15 times 6 is 90. So I want you to take a minute and tell me what you think the distributive property means to you. So I would say as simple as the number on the outside of the parentheses gets multiplied to every term inside the parentheses. The number on the outside of the parentheses gets multiplied to every term inside the parentheses. All right, there's also another cool way of just showing you distributive property using area. So if you take a look at the directions, it says write the expression that represents the area of each rectangle. So if you have a width, a length of 5 and 4, you should know that the area, wait, let's write this down. Area of a quadrilateral is simply base times height or length times width. So on number 1, you would have 5 times 4, and that's 20. And number 2, you have m times 7. Well, m times 7, the coefficient must go first, so you would have 7m. 3 times a would be considered 3a. And on number 4, you have x times x. X times x is simply x squared. Okay, I challenge you to do 5, 6, and 7 without me. So I would pause the video if I were you. All right, 4 times x would give me 4x. And 4 times 3 would give me positive 12. So this would be, I'm going to put some signs here. So this would end up being 4x plus 12. Now, let's put down the positive here and positive there. So on number 6, 7 times a would be 7a. And 7 times positive 9 would be positive 63. So that's 7a plus 63. Number 7, x times x. X times x is x squared. And then x times 2 is 2x, positive 2x. And no, these are not like terms, ladies and gentlemen. They're not like terms because they don't have the same exponential power. This one has a power of 1 and it's invisible, and this one has a power of 2. Write the expression that represents the total length of each segment. All right, that would be x plus 9. I think you guys can slam dunk these 8, 9, and 10. All right, write the area of each rectangle as the product of length times width and also as a sum of the areas of each box. Okay, so we have 5 times x, that's 5x. And we have 5 times positive 7 is positive 35. All right, on number 12 we have x times x, so that would be x squared. And then we have x times a positive 12, so that would be positive 12x. So area as a product, this would mean x times the quantity x plus 12. And area as a sum, that would be x squared plus 12x. That's when it's been distributed. All right, this a times a, please say a squared. And a times positive 8, this a times positive 8 is a positive 8a. So as a product, it's a times the quantity a plus 8, and as a area as a sum, it would be a squared plus 8a. Oh, school's out, ladies and gentlemen. This process of writing these products as a sum uses the distributive property. Use the distributive property to rewrite each expression as a sum. You may want to draw a rectangle on a separate page to follow the technique above. All right. Get out some SSOP, ladies and gentlemen. Okay? Because what we need to do is the following. Okay? Hold on a second. I want to move this page right there. Okay, so on number 14, let's do this. So you have 4, let me see. And then you have x, and then you have that positive 7, you know? So you can do it this way. You can do 4 times x, which is 4x, and 4 times 7 is positive 28. So the answer is 4x plus 28. I don't know if you like the box method. I kind of like doing it a little bit differently. This is how I like to do it. On number 15, I have 7 times the quantity x minus 3. So I like to put a 1 in front of my x, and I like to and draw arrows, okay? 7 times 1x is 7x. And then I go 7 times negative 3, or I know some of you guys freak out when you're like, what, that's not a negative sign. If we were to do keep, change, and I would do plus negative 3, it ends up being a negative 3 anyways. So 7 times negative 3 is negative 21. But people don't say 7x plus negative 21. They just say minus 21. Okay? So please don't get confused on that. The sign in the front tells you exactly what to do. So on number 16, you would have, okay, so now you have negative 2 times 1x plus 4, okay? So you have negative 2 times positive 1x. Now, don't forget the integer rules are coming into play here. You have a negative times a positive. So that would be a negative 2x. And then you have a negative times a positive 4. A negative times a positive 4 is a negative. So, but just put minus 8. There's no need to put plus negative 8. So this one would be negative 2x minus 8. Number 17, you have x times the quantity x plus 9. Okay? Well, let's put our invisible ones. You have a 1x right there. So 1x times 1x is 1x squared. And then you have 1x, and then you have 1x times a positive 9. And 1x times positive 9 is a positive 9x. So this would be x squared plus 9x. Okay? I would love for you guys to try this on your own and pause the video so that you can practice it. It's best to challenge your brain instead of watching me do everything and just copying me. I want you guys to figure it out yourselves. All right. 18, you have a times a minus 1. Okay? So you have 1a, so you have a times a. That is simply a squared. And then you have, again, it's like an invisible 1. You have 1a times a negative 1. Positive 1a times a negative 1 would be a negative a. So this would be a squared minus a. And the same thing, I say negative 1, but like I said, if you k-chopped it, it'd be plus negative 1. It'd be negative no matter what. Okay, number 19, I have 3m times the quantity m plus 2. So let's distribute. Distribute the 3m. 3m times 1m would give me 3m to the second power. Now we'll distribute the 3m to the positive 2. 3m times positive 2 would give me positive 6m. So I have 3m squared plus 6m. All right, number 20. So we have negative 4 times, I'm going to say 1a minus 4. So I have a negative 4 times a positive 1a. That would give me a negative 4a. And I have a negative 4. Remember, I'm distributing negative 4. I have a negative 4 times a negative 4. That ends up being positive 16. So you have negative 4a plus 16. Okay, last one is 21. So you have a times the quantity a minus 12. All right, a times a is a squared. Now what is 1a, positive 1a, times a negative 12? Negative 12a. And they're not like terms because they don't have the same exponential power. All right, moving right along. So let's go to page 10. Now, I would love for you guys to do this on your own and then come back and check the video. So this would be a good stopping point. All right, now let's do this. Okay, now I'm going to help you guys. So we have, I'm going to draw this. Okay, I have 4 times 1x, and I have 4 times positive 5. So that would be 4x plus 20. I have positive 3 times positive 1x. That would give me 3x. And then I have positive 3 times a positive 7. So that would give me positive 21. On number 3, 2 is getting distributed. So you have to multiply 2 to everything inside the parentheses. So you have positive 2 times 6x, and you would have 2 times positive 1. So you would get 12x plus 2. Okay, now we're going to distribute a negative 2. So you have negative 2, you have negative 2 times a 1x, and then we're going to distribute the negative 2 with a positive 5. So negative 2 times 1x is negative 2x, and negative 2 times positive 5 would be a negative 10. Again, you could do negative 2x plus negative 10. Mathematicians don't really do plus a negative, so we just say negative 2x minus 10. Number 5, I have a positive 7 being distributed, and that's a positive 7 times x is 7x. And then I have a positive 7 times a negative 8, and that would be negative 56. So you just write minus 56, and that's it. All right, you have a negative 3 is being distributed on number 6. So you have negative 3 times positive 2x, that would be negative 6x. And then you have a negative 3 times a positive 4, and that would give you negative 12. This one right here is a little tricky because it looks like this. It's like a negative 1 is out there. It's invisible. So you have a negative 1 times x. That would be a negative 1x. And then you have a negative 1 times a negative 10. A negative times a negative is a positive. On number 8, what number is being distributed? Negative 10. Very good. So draw your arrows. I want to see arrows on your papers, ladies and gentlemen. I have negative 10 times 3x. That would be negative 30x. And I have a negative 10 times a negative 7 to give me positive 70. All right, I'm on page 11. And now you might see it a little bit differently. You might see the number getting distributed on like the back end of it. You know, it doesn't matter. You know, it could be in the front, it could be in the back, but 5 is getting distributed. So even though it looks kind of a little wonky, if you wanted to rewrite it, you could. You don't have to, but this 5 is getting distributed. So 5 times 2x is a positive 10x, and 5 times a negative 8 is a negative 40. All right, on number 10, you have negative 9 times positive 4x. A negative times a positive is a negative. And then you have a negative 9 times a negative 11. And a negative times a negative is a positive. So you get positive 99. All right, number 11. So now you have 3 terms. Negative 9 is being distributed. So we have negative 9 times positive 4x. That gives me negative 36x. You have negative 9 times a positive 3y. Well, that gives me a negative 27y. And then you have a negative 9 times a negative 2, and a negative times a negative is a positive 18. And that's it. Okay, number 12. Don't forget that on number 12, this considered here to be like a negative 1. So let's write this out here as a negative 1. So let's draw your arrows. You have a negative 1 times a negative 2x. Negative times a negative is a positive 2x. You have a negative 1 times a positive 5y. That would end up being negative 5y. And then you have a negative 1 times a positive 7, and that would get you a negative 7. All right, number 13. How are you guys doing with this? Do you find it easy? I hope so. So negative 7 times positive 5x is a negative 35x. And a negative 7 times a negative 9 is a positive 63. Number 14, we have a negative 1 being distributed over here. So I'm going to write that. Negative 1. So I have negative 1 times positive 5a to give me negative 5a. I have negative 1 times a negative 8b to give me a positive 8b. And I have a negative 1 times a negative 9 to give me a positive 9. All right, we got 2 more problems, ladies and gentlemen. On number 15, 5 is being distributed on the outside, so you can rewrite it if you want, or you don't have to. But 5 is multiplying 4x, and 5 times positive 5 times positive 4x is positive 20x. And then we have a 5 times that negative 12, so we would have negative 60. And last but not least, number 8. We have negative 8 times positive 12x. That would be a negative 96x. And then you have, oh wait, hold on a second. And then you have a negative 8 times a negative 8y. Negative times a negative is a positive 64y. And then, last but not least, you have a negative 8 times a positive 1, and that would get you a negative 8. And that's the lesson on distributive property. I hope you found it to be easy.
That was easy.
And this is going to be Mrs. Groovy Grove signing out.